Thank you, Dr. West, for the kind introduction. And thank you for giving me the opportunity to present our research on trachoma and household environmental cleanliness in Tanzania. The WHO has promoted a multifaceted strategy to eliminate trachoma called the SAFE strategy. F in SAFE stands for facial cleanliness. E in SAFE stands for environmental improvement. In the past, barriers to clean faces include long distances to water. However, the relationship between other environmental elements and children's facial cleanliness have not been extensively explored. We need improved clarity on household factors associated with trachoma, especially when the disease burden is low and could be maintained. So the purpose of our study was first to understand the association of environmental factors and hygiene behaviors with children's facial cleanliness in Cornwall, Tanzania, where trachoma used to be hyper-endemic, but now, after several rounds of mass drug administration, the trachoma prevalence was at 7%. The second aim of our study was to create a composite household cleanliness index and study its association with trachoma prevalence. Our study was composed of three main parts. In each of the 92 villages in the districts, 20 households were randomly selected for a standardized survey on environmental factors and hygiene behaviors. Many of the variables were based on actual observations instead of reports by households. For example, if a household reported that they had a latrine, but a path to the latrine was not worn, or the latrine clearly had not been used, we did not count it as an active latrine. With regards to facial cleanliness, each child 5 years old or younger at the selected households were observed. The face was considered unclean if either ocular or nasal discharge was present. For trachoma prevalence, a survey was conducted at 50 villages, and in each village, 50 children aged 1 to 9 were randomly selected to assess for the presence of trachoma follicula. We defined a clean yard as a yard that had been swept and had neither garbage nor trash. We also created two composite variables. The first is total time spent on obtaining water, which was one-way travel time times 2 plus the wait time. The travel time or the wait time were categorical variables, so we assigned a score to each category. 1 if less than 30 minutes, 2 if 30 minutes to an hour, and 3 if more than an hour. We also created another composite variable called the household water storage capacity, which was the size of the largest bucket in the household times the number of containers in the household. And we assigned a score to each category of the size of the largest bucket. 1 if it's the same size as a plastic bucket, 0.75 if it was smaller, 1.25 if it was larger. So overall, 64% of households had a swept yard, and a fair number of them had garbage or trash. About a third of households had clothes washed and drying near the house. And the majority of households had an active latrine, but most of these were just pit latrines without a slab and not improved. And as you can see here, most households spend little time in obtaining water. 3 on the x-axis here means less than 30 minutes walk to the water source, and waiting less than 30 minutes for water once they are at the water source. For household water storage capacity, you can see there is a wide distribution among the different households. In the preschool kids, half of them had clean faces. At a household level, 63% of households had at least one child with a clean face. The question is, which environmental factors associated with clean faces? In our univariate analysis, the total time spent on obtaining water was not associated with clean faces. This is in contrast to the 1986 study, which found further distance to water to be a risk factor for unclean faces. One possible reason is that most households now spend a relatively short amount of time on obtaining water. We also found that simply owning a latrine is not associated with clean faces. In the multivariate analysis, we found that water storage capacity is associated with clean faces. The water storage capacity reflects the value placed on hygiene within the family. A higher grade of the latrine was also more likely to be associated with clean faces, because simply owning a latrine was not correlated with clean faces. This suggests that the quality of the latrine matters, and it may indicate a general household willingness to improve environmental conditions. Washing clothes is associated with facial cleanliness in children. It may be that the caretaker just took the opportunity while washing clothes to wash the children as well. It may also reflect an attitude about overall cleanliness in the home environment that includes clean clothes as well as children with clean faces. This idea was further borne out by the fact that clean yard was associated with clean faces. Our criteria for facial cleanliness did not include dirt on the face, so there is no direct link between a household having a dirty yard and a child having an unclean face. Both might just be part of an overall approach to household cleanliness. Based on our findings, we constructed a household cleanliness index that was a summary score of the following markers: clean yard, clothes washed and drying around the house, improved latrine, and at least one child in the household having a clean face. We looked at the relationship of this clean index in trachoma. The x-axis here is the category of the trachoma prevalence in the community. The y-axis is the percentage of households in the community with scores 0 to 4. A lighter blue color means a higher score and cleaner households. When the community prevalence of trachoma was less than 5%, more than half of the households in the community had a score of 2 or higher. If the trachoma prevalence was more than 10%, less than half the households had a score of 2 or higher. To quantify this relationship, we performed an ordinal logistic regression predicting the category of trachoma prevalence in the community by the community average household cleanliness score. We found that half a unit increase in the community average clean index score was associated with a 2.3 increase in the odds of dropping the trachoma prevalence by one category, which is dropping the trachoma prevalence from more than 10% to 5 to 10%, or dropping the prevalence from 5 to 10% to less than 5%. So in summary, a clean household environment is associated with clean faces in children, which suggests a more holistic attitude toward cleanliness. In addition, distance to water is no longer factored in clean faces in the district in Tanzania. We also found that a decrease in trachoma at the community level is associated with average household cleanliness score in the community. Although we do have the limitation that we could not study the direct association because the trachoma survey and the household survey were done at different houses in different times. So most importantly, a multi-pronged approach could be considered focusing on overall household cleanliness, which includes clean faces, latrines, environmental factors such as clean yard, clean clothes, and many more. Thank you for listening.